Find the upper sum and the lower sum for f of x equal 10 minus x squared on the interval 1, 2 with 4 subintervals. A picture would help in this case. This is a parabola, concave down, with the y-intercept being x equal to 0, y equal 10. The x-intercept is the square root of 10, but we won't need it. We're only interested in the area under the curve from x equals 1 to x equals 2. This shaded region from x equal 1 to x equal 2. We see that from x equal 1 to x equal 2, the function is decreasing. Using 4 subintervals, the width of each of the subinterval is delta x, and delta x is always b minus a over n. N is 4 in this case. This is 1 over 4. And so on the number line from 1 to 2, we cut this into 4 subintervals. The first endpoint being 1, we then add 1/4 to it to get 1/4, which is 5 over 4. We then add another 1/4 to it to get 6 over 4. Another 1/4 to get 7 over 4. And another 1/4 to this to get 8 over 4. But 8 over 4 is 2. 6 over 4 is 3 over 2. Using the upper sum, in each subinterval, we would need to use the highest point, the maximum. On the first interval, the width is 1/4, and the highest point is the left-hand point when x equals 1. But then when x equals 1, the height is 10 minus 1 squared, because the height is the value of the function, and that is the area for the first rectangle only. There are 4 rectangles in there because we're using n equal 4. The next rectangle has a width of 1/4 and the height of 10 minus the highest height is the left endpoint, and the left endpoint is 5/4. So this is minus 5 over 4 squared. The next rectangle has a width of 1 over 4 times the height. The height is 10 minus, this time it is 3 over 2 squared. And we still have one more because there should be 4 terms. We're using 4 rectangles. The last rectangle, using the upper sum, the highest point for the last subinterval is at the left endpoint when x equals 7 over 4. The width is 1 over 4 and the height is 10 minus 7 over 4 squared. And we end up with 4 terms. We then use a graphing calculator to evaluate this. But before we do that, we should go ahead and set up the lower sum as well, so that we can use the calculator once only. This time, we will factor out the width 1 over 4, and we simply add the height. But this time, we would only use the right endpoint because for each of the subinterval, the lowest height would be the right endpoint now. So this will be an underestimate. The height for the first rectangle using the right endpoint, x is 5 over 4. So the height is 10 minus 5 over 4 squared. And then the next height is 10 minus 3 over 2 squared. And then the next height is 10 minus 7 over 4 squared. And we need to have 4 terms. The next rectangle has the height of 10 minus 2 squared. Notice that if we factor out 1 over 4, the expression looks much simpler. Regardless, if we use n equals 4, we would need to have 4 terms in the sum. We can now use a graphing calculator to evaluate this. If we evaluate this in a calculator, the upper sum will be approximately 8.03125, and the lower sum will be approximately 7.28125. And again, because the function is decreasing on the given interval 1 to 2, the lower sum is an underestimate. Notice that the rectangles for the lower sum is entirely under the curve, and the upper sum will be an overestimate.